Hi Chem students, in this video we are going to be completing this table together, the first one from one of the video lab data experiments. In the video there were a series of reactions in which a precipitate or a cloudy solid formed. So this would be a precipitate here, precipitate here, precipitate here, 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 here. There are many examples where it remains clear, for instance, this whole row or this whole column, those data points would be aqueous because those solutions still have all their ions dissolved in solution without a solid forming. The table that we are going to do together is related to this solution where a precipitate, that cloudy substance, forms. And in our Google Doc, that is this table, the PPT here for precipitate, where CuNO32 and Na2CO3 meet. When you are doing the table on your own, these tables you will pick for other experiments, but we will do this one together. The first thing it asks is, what are my two reactants? So my two reactants are the column and the row. So one reactant is CuNO32. I'll show you two ways you can do this. I can highlight it. I can press Control C to copy, and I can come down here and press Control V to paste it in. Another way that I can do this is just typing it in. So I will do Na2CO3. When I'm typing in Na2, rather than having a full 2, if I want to do subscript, I can hold the control button in the lower left of your keyboard, CTRL. While I'm holding the control button, I am going to press comma, which is just to the right and above your spacebar. And when I press those two together, it puts it into subscript mode. So I will put Na2, and then I'll hit Control and comma again to take it out of subscript mode. CO, Control comma to put it into subscript mode. CO3. So these are our two reactants. They are the two things that were combined together that formed a solid precipitate. So there are two products that form in this, and we want to find out which one was the precipitate, the cloudy material, and which one is still dissolved in the solution. The way that I will find the precipitate that formed is using the solubility table. When I am looking at this, I want to find which combination either of sodium and NO3 nitrate or copper and CO3, when they swap partners, which one forms the precipitate. So I am first going to look at Na and its combination with NO3 and see what forms here. I find Na, which is in this first row, NO3. Those would not have a reaction form. The product would still be dissolved in solution, AQ for aqueous. So NaNO3 is going to be my aqueous product. That one is going to go here, NaNO3. I do need to check with my ions and predict subscripts. Do I need to add subscripts into this compound? In order to do that, I can pull up a periodic table. Na is in group 1. It has a positive 1 charge. So Na has a positive 1 charge. If I then look at what my subscript is for NO3, NO3 is a negative 1 ion. So Na and NO3, and I like to have kind of a separate piece of paper to help me do this, but I have a positive 1 and a negative 1. They are okay being together. They have an overall charge of 0. So a net 0 charge. So I do not need any subscripts other than the one that is already in NO3. If they did not form a net zero charge, I would need to add subscripts in. But in this case, I'm good to go. My aqueous product is NaNO3. I could add an AQ there if I wanted to, but it's not necessary because I have it in the aqueous product label. So let's check the other combination. Now I'm going to look at CO3 here. So CO3 and Cu to find my other combination. And because we saw a precipitate in the table, I hope that it will show me that a solid or precipitate forms from that new combination. So in this table, I can see copper, Cu, which is a 2 plus ion, copper 2 plus, and CO3, which is a negative 2, and that has a solid form there, which is what I would expect from a precipitate, where I observe that in the reaction. If I look at copper with a 2 plus and CO3 with a 2 minus, those together have a net zero charge, so I would just write it as CuCO3. Now, if I was looking at one, for instance, that had NaCO3, sodium being a plus 1, carbonate being a negative 2, I would have to have two of these sodiums to balance out the two negatives. So it would have to be Na2CO3 if I'm writing the product out. And I can see that in my table where it says Na2CO3. But we don't have to do that in this case. Copper Cu2 plus, carbonate Cu3 CO3 2 minus forms a solid or a precipitate. So that is going to be my precipitate that forms copper CO. I'll press control and comma with the lower script 3. If I wanted to, I could put a S there to mean it forms a solid. And these are the two ions that are removed from solution. Sodium and nitrate are still dissolved in the solution. So if I was trying to remove those through this reaction, it would not work very well. But let's say copper was my toxic ion. Copper is one of the two ions that are removed in this case. And I'm going to go ahead and put the charge with them as well. When I'm doing this, I'm pretty much going to take the thing that's on the left and the part that's on the top. So the two things that form the precipitate, copper and CO3, carbonate, those are the two ions that when they form a solid, they are no longer dissolved in solution. So I will put copper with its 2 plus charge. If I want to do a superscript, instead of control comma, I can hit control period, and then I can then make it a superscript. So that is copper with a 2 plus. I will press control and period to get out of that mode, and then CO doing a subscript, I will do a control and comma to put my 3 in. And then I want to put my charge in. I will press control and period to go up as a superscript and put a 2 minus. So those are the two ions that are removed. And there I have my table. So overall, I'm just taking what are the two reactants. That's what goes in the first part. I'm looking at the new combinations of the positive and negative ions. Remember, the positive is always the first one, the negative is the second. So when I'm using the table, I'm looking at the new combinations, which one is aqueous and still in solution, which one of them is solid and has formed a precipitate. And then if it forms a precipitate, that means that the two ions have been taken out of solution as a result of the chemical reaction. You can pick any four. You do not need to do every reaction. You can do any four of the other chemical reactions up here that are highlighted and use those in the same process. And you can watch this video or ask me questions as needed.